So when you have like terms, you can combine like terms by adding or subtracting them. This is something you should be really good at. You should have learned this, became experts at this in secondary 2. So I just showed you an example. X plus x is equal to 2x. Okay, so my question is, what is the difference between x plus x, which is equal to 2x, and then x times x is equal to x squared? It's a pretty straightforward answer. I pretty much just said it. There's an adding and a, I need my pen. There's an addition sign here, and there's a multiplication sign here. Do those answers look different? They are totally different. So we have to be really, really careful to be able to switch back and forth in our mind of which one is which, okay? Okay, so what did you get when you did 3x plus 4x? You got 7x? Okay, awesome. That is correct. Now, a lot of common mistakes is people will start doing properties of exponents and adding. So they'll say, well, that's 7 and that's x squared. It's not x squared because why? Yes. Everybody's saying the same thing in a different way. It's absolutely correct. This is not a multiplication sign. This is an addition sign. So like terms are like apples, I like to say to people. If you have an apple and then you add it to another apple, how many apples do you have? 2 apples. You don't have apples squared. Like you just have 2 apples. So if I have an orange plus an orange plus 3 oranges, how many oranges do I have? An orange plus an orange plus 3 oranges. 5 oranges. Okay. So just think of like terms as apples and oranges if you need. Okay. So with that being said, I want to review this. You should have learned this in secondary 2 for sure, but I want to review it with you because we're going to build on it somewhat. So when simplifying like terms, so you just saw that you can add or subtract like terms. You have to put it in standard form. How many of you have heard the word standard form before? You all better raise your hand because you've been doing it, especially in secondary 2. So standard form, guys, just means you arrange things from the highest degree, and then the next highest degree, and then the next highest degree, the next highest degree, and to the lowest degree possible. So as long as you put it in order from highest to lowest, you have it in standard form. So just look at with your eyes at these two things. This blue thing here, I'm adding, I have x to the 6th plus x to the 5th plus x to the 4th plus x to the 3rd plus x to the 2nd plus x to the 1st plus x to the 0. Does everybody see how this would be considered standard form? It starts with the highest degree and it works its way down. Now it's not always going to necessarily have every degree in there. It might skip some of them. That's okay. Standard form just means from highest to lowest. Now also we're a lot more advanced than secondary 2. So we know that really if we had an x to the 1st, they wouldn't write an x to the 1st. They'd just write it as an x, right? Everybody? What's x to the 1st? What's anything to the 1st power? Just itself. And really there wouldn't be an x to the 0 there. What would there be? What's anything to the 0 power? 1. So they wouldn't write that. They would just have like a constant number. So in this case, it was a 1. Okay, good. So this is in standard form. All right, so looking at this one right down here, some people tend to say, well, that's not in standard form. You have this 2 in front of this 10. That's not in standard form. It has nothing to do with the number out in front. It only has to do with the exponents. So is this one in standard form? The highest degree was 5, then the next was 4, then 3, then 2, then 1 technically, and then technically x to the 0, because that would be 2 times 1. So does everybody see how this is in standard form? Yeah, okay, we're all good. Okay, then let's go ahead and simplify this. We're going to simplify by combining like terms. We should know how to do this, but I wanted to review it with you again. Because really, in secondary 2, you saw stuff like this, but you kind of saw the smaller versions of these. So now we're getting into, like I said, guys, in secondary 3, it's awesome because you just take what you learned in secondary 2 and go deeper. So we're going to look at some harder problems. You have seen how to do this, but now this is just a bigger, longer problem. So we're just adding these polynomials here together. We're going to combine like terms. So the first thing I like to do is start with my highest degree, my highest power. What's my highest power in this example? 4, n to the 4th. Okay, so I'm going to start with n to the 4th. I'm going to look through and see if there's any other n to the 4th that I can combine this with. So I have 3n to the 4th. Do I have any other 4th powers? No. So we still have 3n to the 4th. And I'm going to cross it out so we don't leave anything out. Let's move on. What would be the next highest degree after 4?
7.
You're right. It's with the negative 7, and you said it's because it's with the n cubed. So our next highest power is 3. So I'm going to look for all the cubes, all the 3's. And now it looks like we only have this negative 7n cubed. So we can't combine it with anything else, so I'm just going to write it in here. Not forgetting the negative. Negative 7n cubed. And I'm crossing it out so I don't forget anything. What would be next?
1.
But in general, let's say we had every single one. What would be next? Degree what?
6.
Degree what?
1.
Degree 2 would come next. In this example, is there any degrees 2's?
No.
No, that's okay. Let's move on. What would come after degree 2?
Degree 1.
Degree 1. Do we have degree 1's? Yes. So we have 5n, and then we have negative 6n. Can we combine those? Yes. 5n's minus 6n's is how many n's? Negative 1n. So I'm going to write negative n, not negative 1n. Is that okay with everybody? That's the same thing as negative 1n. Okay? I just took care of my n's. Awesome. We're all good. And the next thing would be our constant numbers. So we have 3 minus 7. Positive 3 minus 7. Let's combine those. What do we get?
Negative 4.
Negative 4. Very good. Does everybody see how to do something like that? Okay, practice this next one on your own. Ready, set, go. Try this one on your own. Okay, let's go through this one. What's my highest degree?
4.
What's my highest degree? 4. So let's look at all the 4's and combine them. So we have 7n to the 4, and then we have a negative 5n fourths, n to the 4th. So we can combine those. Those are like terms. If you have 7n to the 4th and you're subtracting 5n to the 4th, how many n to the 4th do we have?
2.
2n to the 4th. 2n to the 4th. How many got that? Correct. We just took care of n to the 4th. Awesome. Moving on. The next thing would be degree 3. We have 7n to the 3rd, and then we have negative n to the 3rd. Technically, if we wanted to be technical, what number could we throw in front of here? A 1. So we have 7n to the 3rd plus negative 1n to the 3rd. How many n to the 3rds do we have?
6.
6. 7 minus 1 is 6, so you have plus 6n to the 3rd. Very good. And then it would be degree 2 next. We don't have a degree 2. Moving on, it would be degree 1. We don't have that. So combining those final things, we have positive 1 and negative 6. Negative 5. Questions? Okay, what if you saw something like this? Would it throw you off? And in fact, I bet it will. So we have these with parentheses. P squared plus 4p squared plus 3p squared plus 2p to the 4th. Does that change things or not?
It does, but it doesn't.
It does, but it doesn't. Do you want to elaborate your own? Yeah? No? Okay. So I'll ask you a question to see if you can answer this yourself. What's 2 plus 3? 5. Okay. What's 3 plus 2? 5. Okay. Now, what if I did, I should have done one with parentheses. I should have added one more. Okay, let's go like this. Let's go, well, I just want you to see it for yourself. So let's do a different example. Let's say I had 1 plus 2 plus 3, and I put parentheses around these. What's my answer? 6? We can just add them all up. Okay. So what if I put parentheses this time around these two things? What do we get? We still get 6. You're right. So do these parentheses affect anything? No, they really don't. They're kind of there to kind of trick you. They make it look like, yes, these are in groups. This matters, but it really doesn't. So really you can just pretend like the parentheses aren't there. And since we're adding, we can combine like terms. Now, this would not be true if we were multiplying in here. Those parentheses would be important, but we're adding, so you can just combine like terms. Is everybody okay with that? So let's start with our highest degree. Pretend like the parentheses aren't there. In fact, I'm going to go through and erase them because they don't matter, but just keep in mind that they were there. But we can go through and add like terms, okay? So let's go through and do this. So this is a plus. Here we go. So what's my highest degree? Good, 4. So we have 4p to the 4th plus 2p to the 4th. How many p to the 4th? 6p to the 4th. And then p squared is the next. And so we have 1p squared plus 3p squared. How many p squared? Good, plus 4p squared. Okay, any questions on that? Okay, try this one by yourself and then we're going to move on. Now this one is actually trickier. You have to be really careful. And I'm going to tell you why. That subtraction sign means we're taking this polynomial and we're subtracting that entire polynomial. So before I let you do it by yourself, I'm going to just quickly say one thing. Is the negative going to carry through to both of these things? Yes, because really, if you think about what it's asking us here, guys, think about this. It's this polynomial, subtract all of this polynomial, so you've got to subtract all that stuff. So before I let you combine them by yourself, the negative does distribute through to both. So it comes to here and to here. So what's a negative of a negative? Positive. So you're going to change the sign in here, and then don't forget to change this sign. How many of you have heard the little saying, cross the line, change the sign? No one? Okay, a few people. Cross the line, change the sign. So if you have a negative and it's carrying through to all that stuff, I like to just say, I'm going to cross the line, but then I've got to change the sign on both of those. So this was positive, I made it negative. This was negative, I made it positive. Try it. Okay, so now combine like terms. Combine like terms now. Now remember, for the people that are taking good notes and stuff, you will get bonus on the test for being on task and taking good notes. So keep that in mind. Make sure some of you are not writing it in standard form, so your answer would be considered incorrect on the test. If you're not writing the highest degree first, then the next highest degree, your answer is incorrect. All right, here we go. What's my highest degree? Degree 4. So I'm going to look at my degree 4s and combine them. I only have negative 7k to the 4th, no other 4th, so that's got to come first. Now the reason I like to start with the highest degree is because I'm always writing my stuff in standard form. I promise you I'll mark it wrong on the test, even if you have the right polynomial, but not in standard form. The secondary 3, we have to hold you to a higher standard. Okay, I'm going to cross that out. Now I'm combining like terms. I have 5k and then plus a negative 5k. If I'm combining 5k plus negative 5k is how, and then we have this plus 2k's. So we have 5 minus 5, which is 0k's. Plus 2k's is how many k's? 2k's. Any questions on that? Any questions on that, guys? Okay. Try this one, last one, and then we're going to move on. So make sure you know what you're doing with these because you're going to see them the rest of the year and they're going to get harder and harder and they're going to be longer and longer. And you just got to make sure you know what you're doing. So try this one by yourself. Be careful with the negative, right? We're subtracting all that stuff. Let's a lot, mostly. I'm seeing mostly incorrect. So let's go through this one really quickly together. First of all, I look at this. I know I'm subtracting. Now pay close attention, guys. A lot of you got this wrong, which is okay. We just need to keep practicing these. We'll practice them again next time, but we're going to move on after this. So watch carefully, though, because you cannot make little mistakes, okay? So we have this polynomial right here, and we're subtracting this entire polynomial. So I have to think about this. Technically, it's like having a -1 out in front here. So I got to go through, and I'm going to do my little cross the line, change the sign. Since that was a negative, I want to make it a positive just because it's easier. But if I do that, I've got to cross the line, change the sign. Now watch carefully. I'm going to cross the line. I'm going to change the sign piece by piece. Was this positive?
Yes.
It now needs to be negative. I'm changing the sign. Was this positive? It now needs to be negative. So I'm going to change the sign. Now some of you are still getting it wrong from here. So if you have to rewrite this, just do it. So I'm going to rewrite this without parentheses. I have, at this point, I have 4 minus 3m squared. Then I am going to have minus 5m squared. Is that correct? Everybody? Do you have questions on why I have minus 5m squared? And I'm going to have minus 4. Now I'm going to go through and simplify this. Combining like terms. Very carefully, guys. In secondary 3, we have to get really good at being able to add and subtract negative numbers together. So we have negative 3m squared minus 5m squared. So how many m squareds does that give us? Think about it. You're in debt $3. You borrow $5 more. You're in debt how much? 8. Be really careful. Negative 3 minus 5 more would be negative 8m squared. Okay, so you have to be really careful. With these, you have to pay close attention. You can't be careless for even a second. Let's look at this next one. We have 4 minus 4. What's 4 minus 4? 0. So plus 0. I'm not going to write that. Does everybody that made those little errors see where you made them? Because that's the point of doing this, is to practice and see yes. Yes? Those of you that made errors. I saw a lot of errors. And that's good, because now you're able to see it. Okay, awesome. Okay, we're going to move on to the lesson for today. So this is where you'll want to take notes. We have a lot to learn today, so you're going to have to stay really focused. Today we're going to kind of dig deep into functions. I'm going to just talk about a few things. You've been seeing functions for a very long time. You were focusing on linear functions in secondary math 1, and in secondary math 2 you focused on quadratics. And then in here we're going to focus on, it's kind of a broad focus, but we kind of focus on all of them and just get in deep with all of them. But especially with quadratics, and we do get into exponentials in here. Okay, so what makes something technically a function? What qualifies something to be called a function? So a function is only qualified to be a function if for every x value there is only one, I'm going to underline that, only one y value. So I'm going to say that again. It's only a function, it's only truly a function if for every x value there is only one y value. So remember, looking at like a graph, these are x values right here on this line, and then these are y values. So what that means is that at any point on a graph, every x only has one y value. It's not going to have two y values for one x. You'll see what I mean in a second with some examples. Does everybody have that written down? That's important. You don't need to draw these necessarily. I'm just showing you some examples of some functions. And we'll talk about why they're functions for sure in just a second. Okay. All right, so you guys already know this, but I just want to recap. We're going to talk about the form of a function. Functions really have the form y is equal to some expression involving x. So don't write this down. I just want you to look because I'm just showing you. So I'm just telling you, once again, the form of a function is in the form of y is equal to some expression involving x, depending on what type of function it is. So we have, for example, this would be a function, y is equal to 2x plus 5. That's y is equal to some expression involving x. This is another example of a function, y is equal to 3x squared. This is just y is equal to, this is an expression involving x. Y is equal to e to the x. Also a function. It's just some expression involving x. Y is equal to 2 times 3 to the x. These are all forms of a function. So you guys all know what a function looks like. You've been seeing them for a while, but I just wanted to talk about that really quick. Okay, so now this might be new to you, talking about input and output. Now you do briefly talk about it in secondary too, but we need to you'll want to write this down. We have to talk about input and output of functions. Input and output of functions. So every function has the form y is equal to some expression involving x. With that comes every function will have an input and every function will have an output. So x in the function, x will be the input. That's what you plug into the function to get the output, which will give you y. So y is our output, and that's the answer that you get once you plug in a number for x. So once again, our x of our functions, the input, our y of our functions, the output. Does everybody understand? X is input, y is output. In, out, okay? Any questions on that? Now here's an example of what I'm talking about. If I gave you the function, y is equal to 2x minus 3. An example of an input would be like putting in a 1 for x. Or putting in a 1, you see how I'm substituting in a 1 for x. I'm inputting a 1 for x. That would be considered the input. Now if I plug in a 1, we could go ahead and calculate this value. We could do 2 times 1, which is 2. And then we could subtract 3, which is negative 1. So our answer would have been negative 1. Does everybody understand that? So this would be our output. So we have an input. Once we put it in and we calculate it, we get the output. So it's not a hard concept, but it is different wording than what you're probably used to. Does everybody see how I did that? Input, output, and I even color coded it so that you could see what each thing is. Are we all good? Okay, awesome. Does anybody need another second writing? Okay, so once again, input, output, all these functions have inputs and outputs. I just showed you that the input's the x, the output's the y. I just went through, you don't need to write this down, just look. Does everybody understand input, output? It works for every type of function. Are you all okay with that? Just looking at this, does that make sense? We could plug in any number for x and we would get an output. Input, output. Input is what?
X.
And output is
Y.
y. Thank you. Okay, so now a way you can kind of test an easy way, this isn't a truth, like this isn't a mathematical practice or anything, but it's kind of a neat way that you can kind of test to see if a function is truly a function, or I guess if a picture you're looking at is truly a function. So have any of you heard of the vertical line test? The horizontal line test. I say vertical because your pencil's held vertical. The horizontal line test, has anyone heard of it? Well, okay, awesome, yes. So a few of you have, but it's not an actual mathematical practice, but it's a way to easily take your pencil or take a line and you're going to hold it up like this vertically and you're going to go horizontally across and you're going to see if that function touches your pencil twice on the y-axis. So if it does, then it's not a function. So it's an easy way for you to just say, is there only one x, or is there only y for every x? So let's look at this, for example. If this is my pencil, I wish it was bigger. Maybe I should get a bigger one. And I take it and I run it across. Does it ever hit on up and down? Does it ever hit my pencil twice in the same spot?
Yes.
Where?
No.
So look, it's going. And those are going to continue to grow up that way forever. So is it ever going to hit my pencil twice up and down in one spot? No, so this is truly a function right there. Sweet. Now look at the line. If I'm going across, does it ever hit my pencil twice in one spot? No, so that would be a function. Now looking at this one, you have to think really carefully, and when you see some examples of non-functions, it will make more sense, but look carefully at this one. This one is actually a function. Now watch, if you watch carefully, now keep in mind, this arrow is never going to just start growing this way. It's always growing forever this way, and this is forever going that way. So if I went across this, even though it gets really steep, it's never going to cross my pencil twice in one spot. So that's kind of how the horizontal line test works. But really what we're just checking for is we're looking to make sure that every x only has one y. All right, let's do some more. Well, this is going to make more sense once you see some, because it's hard when you don't see examples that aren't functions. So once you see the examples that aren't functions, it will make more sense, I promise. So let's look at the circle first. When my pencil's going, does it hit my pencil on the top and bottom in one place all at once? Yeah, so look, if I had a line right here, does it hit my pencil in two places for one x? I'm at -3, and it's hitting it has two y values. Do you see how it has two y values? Does that make better sense? Okay, so I knew that it would probably be a little bit weird until I got to the actual counter examples. So once again, I'm drawing. If I drew a line right there, I'm at x is equal to what? Can you see that part? 3, is it hitting my pencil on the y's in two places? Yes, so this is not a function. Let's test out this little guy. If I'm drawing a line across, does it ever hit my pencil twice in one spot on the y? Right there. Is there another piece that this function's hitting it anywhere? What about right there? I look up and down. Is there anywhere else that it's hitting my function up and down? What about right here? Is there anywhere that it's hitting my function up and down again on the top or bottom? No. Does that make sense, everybody? Okay, awesome. Okay, let's look at this one. I'm going to draw a line right there. Yikes! At -3, does that hit my pencil in more than one place? On the y's. Yeah, it hits it right there, and right there. This is not a function. Does that make sense, everybody? Are you all okay? Okay. What about this one? I'm going, and I'm drawing a line.
Yeah.
I'm at -1. Does it hit my pencil twice on the y-axis? Right there and right there. Is that a problem? Yes, this is not considered an actual function. Okay, so now I'm going to have you guys practice. Go 1 through 9 on the front of the worksheet. Determine if those are functions or not. Do the line test. If you need to draw the line and say, okay, do I see where it would hit it twice? That's a problem. If it's not hitting it twice anywhere, it is a function. Now ignore the domain and range. That's what we're learning next. Ignore the domain and range. So go through and decide, are those functions or not? You can talk to your neighbor. Please do. Check with them. If you're having problems, a lot of your neighbors are getting it, so have them maybe try to explain it to you if I'm not saying it in a way that maybe is understandable. So ask them for help. Okay, so now we need to talk about how functions can be represented in many different forms. So what you need to understand is that functions, like those pictures that we decided were functions, they all have equations, which has a table, and we were looking at the graph. Now, looking at these, for example, you don't need to write these down, but just look. I want you to understand. Functions can be written in different forms, or you can represent them in different forms. So, apples and apple juice, same thing, different form. Apples and applesauce, same thing, different form. That's how functions are. So functions can be represented as an equation, as a table, and as a graph. So think about it, guys. I could use this equation. I could plug in some points for x. So let's say I plugged in -2. -2 minus 2 is -4, right?
Yeah.
-4 squared is? -4 squared is positive 16. You guys, -4 squared is -4 times -4, which is positive 16. Is that what they got? So they're just making a table of values. They're equal. As long as we plug in some values, we can get these equal things. Look, if I plug in a 0 for x, my input, if I plug in 0, I have -2 squared. -2 times -2 is positive 4. Is that what they got? So does everybody see how these are the same thing, different forms? And then we could take these x, y points and we could graph it. And that's what it would look like. Does that make sense how they connect? Okay, awesome. Okay, so now we are going to get to domain and range. How many of you should have heard you do talk about domain and range in secondary 2? Please tell me you know what domain and range. Briefly, at least does the word sound familiar? Yes, okay, good. So we're going to talk about domain and range. So domain, you will want to write this down. So domain of functions is all the possible x values And we know that x values are input values. So it just means all the possible input values. Once again, domain is x. You'll hear me say that all the time. I'll shorthand it and I'll say domain is x values. Range is y values. So range is all the possible y values of the function, or all the possible output values. I'm going to be saying, I'm going to keep it simple. The rest of the year, I'm going to be saying domain is x, range is y. So you just have to keep in mind that we're talking all possible x values and all possible y values. So domain is x, range is y. You have to remember that the rest of the year. I'm going to say that one more time. Domain is x, and range is y. I do? Where? Input with 2 P's. I'm trying to put an emphasis on the put. Thank you. I'll get that fixed. Okay. So domain is x, range is y. So I want to say this too because I say this a lot and I think it really helps my students understand and kind of see. Should be able to really see what domain and range is. So domain is x. X is left and right. If you looked at an XY chart, X, Y. Domain is left and right. Does everybody get that? And range is up and down, up and down. Does everybody understand that? Okay, because that's what I'm going to say a lot too, and it really helps visualize. Because if you look at it that way, the next part won't be so confusing. Now, if you're zoned out at all, you're going to be so lost on this next part, so you're going to want to start focusing now. Because this is where it gets a little bit tricky. Okay? But as long as you're paying attention, it shouldn't be too bad. Okay, so we're going to look at this function in particular. This is our first example. We're going to look at this function, and we're going to determine the domain. We're going to determine the range. So let's start out with domain. Now we're going to have to get really good at being able to focus with our eyes in the right spots. Okay? All right, so domain. Looking at this function, well, first of all, this is a quadratic function. Now we're talking domain. We just talked about how domain is x values. I just said x values are left and right. Is that true? So we're going to determine where this function is growing from left to right. Okay, before we do that, does everybody understand I could keep counting this way for forever till I got to infinity? Which infinity is a really cool number because it's not a number. We can't actually grasp, like our brains cannot quite grasp what infinity really means. But keep in mind, infinity is not an actual number. It's just a thing that we can't comprehend, but we know it's really large, right? And in the x direction, this is negative infinity, right? It's just going to get smaller and smaller and smaller, and it's going to grow forever to negative infinity. Okay, so now I want you to focus your eyes. Left and right. This, it does not matter. I'm telling you right now, for domain, it does not matter that this is growing up at all. It doesn't matter that this is growing up. I'm talking left and right. So tell me, where is this graph? It doesn't matter that it's going up. We're talking domain. Domain is left and right. Where is this graph growing this way? Where is it growing to? Look at it. It doesn't matter if it's going up. I'm talking this way. Where is it growing to? Negative infinity. Does everybody see how this graph is going up, but it's growing this way? It doesn't matter that it's going up. It's growing this way to negative infinity. Are you all okay with that? Okay, so I'm going to write negative infinity, comma. Now let's talk about infinity. Let's talk about the other side. Where is it growing right? It doesn't matter that it's growing up. I'm talking domain. That's left and right. Where is it growing that way? It's growing to positive infinity. Okay, awesome. Now this is in bracket notation. Now, interesting fact for you. Infinity has to have parentheses. So parentheses means it doesn't include it. But the reason we put parentheses around infinities is because we can't peg infinity as an actual number. It's not a number, it's a place. Like we can't comprehend what infinity is. Does that make sense? So infinity, no matter what, will always have parentheses. Okay, now let's talk. Is everybody okay with domain? Because if not, we gotta get that. Okay, range. Range is y value. So now you gotta shift your eyes, shift your brain. It does not matter that it's growing that way and that way forever. We're talking up and down. So let's look at this. I'm gonna start from the bottom and work my way up. Starting from the bottom. Where does my graph start?
0.
At 0. We don't care how far left and right. We're talking up and down. Does everybody see how that starts at 0?
Yes.
Okay, so it's starting at 0. Did it include 0? Did it touch down on 0? Yes. So we're going to put a 0 and we have to put a bracket. The bracket means it included 0. Does that make sense, everybody? Well, now we're looking up and down. It started at 0 and it's growing up that way forever. So where's it growing to? Positive infinity. And then we always put a parenthesis around infinity because we can't really peg infinity as a number. Questions on range? This is really hard for a lot of students, so really please ask. That's why I'm kind of going so slow. Okay. Let's do another one. Let's look at this one. They get a little bit trickier. Okay, looking at this one, I'm going to ask you, let's find the domain. Now, do not look up and down. It does not matter that it's growing up. It doesn't matter if it's growing down. We're talking left and right only. So tell me, this group, I want you to think about it, and I'll let you tell me in a second. Everyone's going to think about this. What's the domain on this one? Everybody think, and then tell your group. Ready, set, go. What's the domain on this one? It does not matter that it's growing up and down. I'm talking left to right. Where's it growing? Not up and down. Do not look up and down at all. Look left to right. Where's my graph growing? Tell your neighbor. Okay, you all see it? You all see it? Okay, what did you guys come up with? Where's it going this way? Negative infinity, forever. So negative infinity, and where's it growing this way? Positive infinity, and infinity is not a number. We can't peg it as a number, so we put parentheses. All right, now this time I'm going to have you think very carefully. What is the range? Ask your neighbor what they think. Now, it does not matter that it's growing left and right. I'm asking you up and down, where is this growing? Ready, set, go. Tell your neighbor. Okay, I heard a lot of good things. So starting from the bottom to the top, I'm like, where's my graph? Oh, it starts at what? Negative 5. Well, did it include negative 5 or was that an open circle?
Yes.
It includes negative 5 and it's growing forever to positive infinity. Very good. So I need to put a bracket. It included 5 and then positive infinity. Okay. Any questions? This one's a little bit trickier. Give it a try. Ready, set, go. Do it with your group. Do the domain and the range. Now I'm going to remind you, this one looks a little bit trickier, but if you shift your eyes the correct way, you're going to get it right. Domain is left and right. Do not look up and down. It doesn't matter for domain. I'm talking left and right. Group 5. Group 5. Somebody from the group. What conclusion did you come up with? Domain. So I'm asking you guys, left and right, where did you decide this graph was growing to? So you said that it was growing to negative infinity, and then what? And positive infinity. It didn't matter that it was growing down. I'm not even looking at that. I'm looking left and right. It's growing forever this way and ever this way. You're right. Good job, group 5. Negative infinity to positive infinity. All right, range. This group got it right, so I'm going to ask you, what's the range on this one?
Positive 10 and negative infinity.
Oh, you guys saw that it started at positive 10 and grew to negative infinity. Good. How many of you got that right? I want to see by a show of hands. Nice, nice, nice. Okay, so here's a fun fact for you, though. You're right, it started at negative 10 and it grew to negative infinity. So fun fact for you, though, you need to write the smallest number first. So you're going to write negative infinity because obviously that's much smaller than 10. Does that make sense, everybody? So make sure you put brackets around 10. Did it include 10? In this example, it did. Questions? Okay. What's the domain on this one? Left and right, where's this graph growing, guys? This is really important. Negative infinity to positive infinity. Good. And what is my range?
The same range.
Good, it's growing up forever that way, and it's growing down forever that way, so our range is also negative infinity to positive infinity. Okay? This one's the tricky one, and then I'll let you work. I'll let you work, I promise, but you guys need to stay with me. Alright, try this one with your group. Domain and range, this one's trickier. Domain is x values, we're talking left and right. Range is y values, up and down.
1, 2, 5. Okay.
Domain, we're looking left and right. Where's my function? What does my function contain from left to right? What are the numbers between? Oh, it started, we're looking left and right, not up and down. So you said at negative 3, and it grew to 4. You're right. Negative 3 to 4. Did it include negative 3 and 4? What if this would have been an open circle? It wouldn't, we would have just done a parenthesis, right? It'd still be that. Okay, so we have negative 3. Whoa, I'm not writing. Negative 3 to positive 4. Now it included negative 3, so I bracketed it. It included positive 4, so I bracketed it. Now if that would have been an open circle, it still would have been 4, but just a parenthesis. Does that make sense, everybody? Okay. Now how about range?
1, 2, 5.
Now we're talking up and down.
1 to 5.
From 1 up to 5. Very good. Did it include 1 and 5? 1 and 5. Very good. Okay, I'm going to ask you one quick question though. If I went like this and changed the middle, you guys pay attention. If I changed the middle to do this, would that change? Oh, I shouldn't have gone below that line. Would that change our, well, let me go like this. This is what I was trying to get at. This is better. This is what I was trying to get at. Would, if I drew it like that, change our domain and range?
It would change your range.
It would change the range because I'm not drawing very good. I'm not getting my point across because I wasn't paying attention. Okay, so if I made this just a little bit higher, looped it around like this, and then connected it back, would that change my domain and range? No, so all the in-between doesn't matter. Does that make sense? Really bad example, but I wanted to throw that out. Okay, go back and determine all the domain and range on problems 1 through 9 on the worksheet. I don't think you need that last example. I'm going to skip it. Domain and range on problems 1 through 9 on the worksheet. I'd want to take notes if I was you. Now remember, this is where I'm teaching, and you're not supposed to be talking, okay? Because it's way distracting. Okay. So we're now in secondary 3. We're going to be using function notation pretty much from now on instead of y. So function notation just means we're going to be using f of x instead of y, but they're the same thing. So just keep that in mind, okay? So f of x is just another way of saying y. It's just the proper way of saying it. It's saying we have a function of x. You've seen function notation before, right, everybody? I mean, you definitely should have. Function notation is the exact same thing as a y. It just means we have a function of x, okay? So just in your notes say I'm using f of x, not y. So for example, don't write any of this down. I'm just showing you. Y is equal to 2x plus 5. We're using function notation from now on, so we're going to use f of x is equal to 2x plus 5. This just means the same thing as y, it's just we're saying we have a function of x. Does everybody understand that? Same thing, different way of writing it. This is the more mathematical way of writing it. So look, these are the same thing, it's just I'm saying I have a function of x. These are the exact same thing. I'm just saying I have a function of x. Looking at this one, we have y is equal to 2a plus 5. I'm writing it in function notation, so that just means I'm not writing a y, I'm writing f of a because it was a function of a. Does that make sense, everybody? We're using function notation. So this is a function of b. Just like a y though, same thing though, same exact thing. This one has a c in it, it's a y, but we're going to write it in function notation, so we're saying we have a function of c. Does everybody understand that? Okay. Now understand it's not always going to be, f is like the one they always use, but if they were using like 2 of them, they might use like g of b instead of writing an f, they might not always use f. F is just nice because it like flows, so you say function of x, but it would mean the same thing if we were to use g of b is equal to 3b squared minus 2. Or I could do t of b is equal to 3b. Does everybody understand? It's just a different way of writing things. It means the same thing. Okay. So let's go ahead and practice evaluating a function using function notation. So I'm given f of x is equal to 2x plus 3. It wants us to find f of 2. That simply means we're going to plug in 2 for x. Does everybody see how instead of an x there's a 2? So what we're going to do is go through and plug in a 2 wherever there's an x. So we have 2 times what? 2 plus 3. All right, let's simplify that. Now f of 2, that's not going to calculate into this. That just means I want you to plug in 2. So our final answer is going to be 4 plus 3, which is equal to 7. So our final answer is f of 2 was equal to 7. That just means our function, when we plugged in 2, was equal to 7. Does that make sense? People start trying to go, oh, well, what about this f of 2? That's just saying our function, when we plugged in 2, was equal to 7. Are you all okay with that? Let's do another one. F of x is equal to 1 over 3x minus 1. What's f of 3? What do you think I'm going to do? Plug in a 3. So f of 3, does everybody see instead of an x there's a 3? So I'm substituting in a 3. So I have 1 over 3 times what? 3 minus 1. If we simplify that, we're going to get 1 over 4 minus 1. Oh, 4. Not 4, but that's an easy change. That's 9, right? 3 times 3. So 9 minus 1. So we have 1 over, what's 9 minus 1? 8. Okay, good. Okay, good. What about this one? F of x is equal to x squared minus 3x minus 5. Find f of negative 2. What do you think I'm going to do? Substitute in a negative 2. So I have to make sure I'm really careful because wherever there's an x, I'm substituting in a negative 2. Notice instead of an x, there's a negative 2. So I've got to put parentheses around this part. Negative 2 squared minus 3 times negative 2 minus 5. Does everybody see how wherever there's an x, there's just now a negative 2 substituted in? And then we would simplify that. I'm not going to simplify that right now. So we're going to move on. Is everybody okay with that? This is not new. You should have done this in secondary too. This is considered in the book a review problem. So most teachers don't teach it because you already know how to do it. Okay. Okay, so I'll let you, well, no, that's going to have to be homework, okay? Because we need to make sure we can do this as well. We just can't fall that much behind. We have to keep going. So I apologize that you are going to have homework tonight. So do you guys all know how to multiply polynomials, or do you want me to go over it really quick and then you can do that as homework? Are you ready to just work on the rest of the worksheet? It's up to you at this point. Because it's supposed to be like you already know how to do it, but I would love to go over it. That's why I have these up here. Do you want me to review how to multiply polynomials? Okay, so let's look at this one. We have x times 2x plus 3. We have x times 2x plus 3. What we're going to do is we're going to distribute this through and make sure we multiply it to everything. So because it's really just x times 2x plus 3. It's this times this entire thing. So we're going to distribute that through. So what's x times 2x? 2x squared. And then we have plus, what's 3 times x? 3x. And we're done. Does that make sense, everybody? Let's do another one. Negative 2 times 3x squared plus 2x minus 3. Once again, it's this polynomial multiplied to all of this polynomial. So I like to draw my little arrows. To be honest, I never don't. Because why not? It takes me 2 seconds and I make sure not to miss anything. So I've got to multiply that through to everything. So that means I'm going to have, oops, hold on. Let's not get ahead here. So we have negative 2x. Let's be careful. This one's kind of tricky. Negative 2x times 3x squared. What do we get? Negative 6x what? cubed. Good. And then we have, does everybody get where I got negative 6x cubed? Okay. Negative 2x times 2x.
4.
Is it positive 4?
Yeah.
No.
Negative 4x what?
Square.
X squared. Good. And then negative 2x times negative 3. Plus 6x. And then I would combine my terms if I could. But in this case, I can't. Does that make sense, everybody? Now I just want to say one last thing. One last thing that I'll let you work for the rest of the time. If you saw something like this, do you guys remember how to multiply binomials? Double distribute, right? Okay, so I just want to make a point here. I'm going to do this last example. If you're given something like this, 2x minus 1, it would not be okay. I promise you, you would get the wrong answer if you were to think you could go like this. 2x squared and negative 1 squared. If you think you can just square that and square that, you will get the wrong answer. You absolutely cannot do it. It's called the forbidden rule by my book, so Miss Christensen's forbidden rule. If you ever have negative 2x minus 1 squared, you can't just square both of those. You'll get the wrong answer, I promise. So what you're going to want to do when you see something like this, you guys, is rewrite it as 2x minus 1 times 2x minus 1. Does that make sense, everybody? Is everybody okay with that? I promise you will not get the same answer if you just square both of those. Let's go through and quickly do this one. 2x times 2x. 4x squared. I'm going to double distribute. I always draw my rainbow no matter what. 2x times negative 1. Negative 2x. Now, do not forget this part, guys. This is where most people forget. You now got to double distribute the negative 1 through. Negative 1 times 2x. Negative 2x. And I've got to distribute negative 1 times negative 1 is positive 1. Now we're going to combine my terms. So we have 4x squared. Now be careful with this next one. Don't make any negative adding errors. Negative 2x minus 2 more x's. Negative 4x. And then we have plus 1. That would be my final answer. Does everybody promise me you're not going to break the forbidden rule? Promise me. I promise, Miss Christensen, I'll never break the forbidden rule. Okay, well, I believe you. I believe you since you chanted it like that. Okay, ready, set, go. Finish up the worksheet. It's due in 2 days. So you have 2 days to come get help and to watch my videos. So it's due on A-Day, next A-Day. Yeah? Okay.
I get out after